8 days ago, a telescope in Chile saw something that four of humanity's most powerful space telescopes had missed for over 20 years. Same patch of sky. Hubble had looked at it. James Webb had looked at it. So had two other major observatories. And Rubin's new image, stacked right on top of theirs, showed something none of them caught. I'll be honest, when I first saw the number attached to this, I thought it was a typo. It wasn't. And that's not even the strangest thing this machine has done in the last 12 months. In under a year of partial operation, it found a rock the size of a skyscraper spinning so fast it should be tearing itself apart. A star that may have died without an explosion. No flash, no warning, just gone. And a visitor from another solar system that nobody noticed had passed by, until scientists checked footage Rubin had already quietly captured 10 days before anyone else caught it. This is the story of the Vera Rubin Observatory. And by the end of this video, you'll understand why the astronomers working with this data keep using the same word, unsettling. So what exactly is this thing? Forget everything you know about how telescopes normally work. A normal telescope points, focuses, captures one image. Done. Hubble gave us incredible detail. James Webb gave us the ancient infrared universe. But neither of them was built to go back to the same patch of sky over and ask what changed since last time. Rubin was built around exactly that question. Every 3 to 4 nights, it photographs the entire visible southern sky. Not a galaxy, not a region, the entire sky. Then it compares that image to the one before it. If a single point of light moved, brightened, dimmed, appeared, or disappeared, the system flags it instantly. And here's the number that should stop you. Once the system hit full operating speed, it started generating close to 7 million alerts every single night. Let that sit for a second. 7 million things changing in the sky every night that this one machine is catching in real time. To understand how insane that leap is, go back to the very first image this telescope ever released. Just 10 hours of test observations spread across 7 nights. One composite image. Inside it, roughly 10 million galaxies. Not stars, galaxies. Each one potentially holding billions of stars of its own. And according to the observatory's own team, that jaw-dropping number was only a tiny fraction, about 0.05%, of what Rubin expects to capture across its full 10-year survey, which is projected to reach around 20 billion galaxies. We've barely opened the door, and the room is already too big to see the walls. Scientists have started describing this telescope in a very specific way. It doesn't just photograph the universe. It gives the sky a memory. And a universe with memory behaves completely differently than a universe frozen in a photograph. A missing star becomes a clue. A shifting dot becomes an asteroid. A faint smudge becomes something nobody's ever cataloged before. Which brings us to the first object that made scientists stop scrolling and start double-checking their instruments. Because it's not just strange, it's a rock the size of a skyscraper doing something that shouldn't be physically possible. Its name is 2025 MN45. On paper, it sounds like just another rock drifting in the asteroid belt between Mars and Jupiter. But the moment astronomers actually studied how it moves, it became one of the strangest objects on record. This asteroid was found by Rubin's own Simone survey telescope back in May 2025, before the real 10-year mission had even formally started. It measures roughly 710 meters across. That's almost twice the height of the Empire State Building tumbling through open space. Here's the detail that made scientists stop and check their data twice. This asteroid completes a full rotation once every 1.88 minutes. Under 2 minutes for something the size of a skyscraper to spin all the way around. To understand why that's alarming, you need to know what most asteroids this size are actually made of. They're not solid rock. They're what scientists call rubble piles, loose collections of rock and dust barely held together by their own weak gravity. Like a pile of gravel floating in the dark, clinging to itself out of habit more than physics. A rubble pile spinning that fast shouldn't survive. Centrifugal force should rip it apart and scatter the pieces across the solar system. But MN45 is still there, fully intact, still spinning at a rate researchers openly admit they never expected to find in an object this large. So what's holding it together? The leading theory is almost as wild as the discovery itself. This might not be a rubble pile at all. It might be a fragment blasted off the dense, superheated core of a much larger planetary body, one that existed early in our solar system's history before it was destroyed in a violent ancient collision. If that theory holds, MN45 isn't just a rock. It's a surviving piece of a planet that no longer exists, spinning through the dark for roughly 4.5 billion years. And we only just noticed it. And it wasn't alone. That same round of observations turned up over a dozen other fast-rotating objects, several of them spinning nearly as strangely. Now, zoom out even further. During Rubin's pre-survey testing phase, while the telescope was still being calibrated before the real mission had even begun, it identified more than 11,000 previously unknown asteroids, including new near-Earth objects. And that was essentially a warm-up run. 11,000 new asteroids before the telescope had even officially clocked in. That's not a discovery. That's a preview of what happens when this thing runs at full power for 10 straight years. And asteroids aren't just floating debris. They're historical records. Each one carries evidence of how planets formed, collided, and settled into place billions of years ago. Which means somewhere in that flood of new data might be the key to finally understanding how our solar system got built. But a spinning rock isn't the strangest thing this telescope has found. Because in early 2026, Rubin caught something that doesn't spin, doesn't orbit, doesn't glow. It just disappeared. Scientists call it a failed supernova. And it might be the strangest way a star can die. Normally, when a massive star reaches the end of its life, it goes out loud. It explodes outward with enough force to briefly outshine an entire galaxy. That's a supernova. Bright, violent, impossible to miss. A failed supernova does the opposite. Instead of exploding, the star just collapses straight inward, straight into a black hole. No blast, no flash, no warning. One moment there's a massive star. The next moment, there's nothing where it used to be. For decades, this was only a theory because catching one is uniquely hard. You're not looking for something bright. You're looking for an absence. A star that was there and now isn't. In a universe filled with billions of stars that all look the same until one of them quietly stops existing. In February 2026, astronomers using Rubin's data pinpointed a possible candidate for exactly this. A star in the Andromeda galaxy, roughly 2.5 million light-years away, that may have gone dark without ever exploding. Researchers working on Rubin's alert systems say the telescope is uniquely built to catch these events because its images reach roughly 100 times fainter than anything other surveys could see before. Which means every previous telescope on Earth was simply too weak to notice this kind of death happening. If this candidate is confirmed, it's direct evidence that some of the universe's biggest stars are collapsing into black holes in complete silence, which means there could be far more black holes scattered across the cosmos than anyone has ever counted. And stars aren't the only things slipping past unnoticed. In all of recorded history, astronomers had only confirmed a small handful of objects that came from outside our solar system entirely, visitors passing through from other star systems before continuing on their way. One of the most recent was an interstellar comet, first announced in mid-2025 after a separate telescope network spotted it. Here's the part that genuinely surprised researchers. When astronomers went back and checked Rubin's own archive data afterward, they found Rubin had already photographed that same object 10 full days before anyone else on Earth even knew it existed. 10 days, sitting quietly in the data. Nobody had looked yet. Think about what that actually means. A telescope that can look backward and notice a visitor from another star system that already came and went undetected in real time. A star in a neighboring galaxy that may have died without a single flash. And an alert system processing millions of changes to the sky every single night. More than any team of human astronomers could ever fully keep up with. This isn't a telescope anymore. It's a live surveillance system for the entire visible universe. And everything we've covered so far, the asteroids, the vanishing star, the silent visitor, all of it is still just the surface. Because 8 days ago, this same observatory quietly released something that goes deeper than anything we've talked about yet. Here's the story most space channels haven't caught yet. 8 days ago, Rubin released a new image of something called the cosmos field, a small patch of sky that happens to be one of the most obsessively studied regions in the entire universe. Astronomers picked this field decades ago and pointed everything they had at it. Hubble looked at it. James Webb looked at it. So did the Chandra X-ray Observatory and the Spitzer space telescope. For major instruments, for different ways of seeing light, all staring at the exact same coordinates for over 20 years. And now Rubin has laid its own exceptionally deep view of that field directly on top of all of them. Think about what that actually is. It's not a new discovery in the way MN45 or the Andromeda candidate were. It's something rarer, a direct comparison. The same patch of sky seen through 5 completely different sets of eyes, stacked together for the first time. Together, these overlapping surveys turned cosmos into one of the most intensively studied regions in the sky, with each observatory contributing a piece of the story that the others physically could not see. Where Hubble sees visible light, Rubin sees faint wide-field detail no single target telescope was built to catch. Where James Webb sees deep infrared, Rubin sees motion and change across the same field night after night. It's not that Rubin is better than any of them. It's that for the first time, we're seeing what happens when you let all of them talk to each other, layered over the same 6 by 6 arc-minute patch of sky. And this isn't even the finished picture. A second phase of this data is expected between October and December of 2026, which will add difference images, frames that isolate only what has changed, and comparison templates that reveal motion no single snapshot could show. Which means the Cosmos release we're looking at right now isn't the end of the story. It's the opening frame of one that's still being written, month by month, for the rest of this year. So, we've got a telescope that found a fragment of a shattered planet spinning nearly 5 times faster than physics comfortably allows. A star that may have died in total silence. A visitor from another solar system caught only by accident, 10 days late. And now a stacked view of the sky that 4 of humanity's greatest telescopes have been staring at for 20 years, finally seeing the way none of them could see it alone. If this is what a data release from last week looks like, what happens when the real 10-year survey is running at full strength for years, not weeks? To answer that, we have to go back to why this telescope exists in the first place. And it has nothing to do with anything we can actually see. Everything we've talked about so far, the asteroids, the vanishing star, the interstellar visitor, even that stacked cosmos image, all of it is the part of the universe we can actually see. Here's the number that should make you sit back in your chair. Everything visible in the cosmos. Every star, every planet, every galaxy, every human being who has ever lived, makes up only a small fraction of what actually exists. The rest is made of dark matter and dark energy, 2 forces that dominate the universe that scientists still cannot directly explain. And this is where the story gets personal, because this observatory wasn't just named after someone at random. It was built specifically to hunt for the thing she first proved was real. Vera Rubin was an American astronomer working in the 1970s. She spent years studying how galaxies rotate and noticed something that didn't add up. Galaxies were spinning so fast that, based on the visible matter inside them, they should have been flying apart entirely. Something invisible had to be holding them together, providing gravity that no telescope could see. That invisible substance is what we now call dark matter. And her observations became some of the strongest evidence that it exists. She never lived to see this telescope carry her name into operation. But in a very real sense, this entire 10-year mission is the continuation of the question she first asked half a century ago. What is actually holding the universe together? Here's how the observatory plans to answer that. As light travels across the expanding universe toward Earth, it stretches, shifting toward the red end of the spectrum, a phenomenon called redshift. The more stretched the light, the farther away its source. By measuring this shift across billions of galaxies, Rubin can map how mass, including the invisible kind, is distributed across distances we can barely comprehend. Astronomers who've already tested this technique on Rubin's early data say it's performing at least as well as anything else currently in operation. And once the full survey wraps, Rubin is expected to measure the redshift of roughly 4 billion galaxies out of the 20 billion it will ultimately observe. Dark matter is only half the puzzle. The other half is dark energy, the mysterious force that appears to be causing the universe's expansion to accelerate instead of slow down. By tracking hundreds of thousands of a very specific kind of exploding star every year once the survey reaches full speed, Rubin is expected to give researchers one of the most detailed independent tests ever conducted of whether dark energy behaves as a fixed constant, or whether it's been quietly changing throughout the history of the universe. If it turns out dark energy is evolving rather than fixed, that wouldn't just be an interesting footnote. It would be one of the most significant findings in the history of physics, forcing scientists to rewrite what we think we know about how this all ends. So, let's step back and look at the full picture one more time. In under a year of partial operation, this telescope produced a single image containing 10 million galaxies, a number that turned out to be a fraction of what it's ultimately built to capture. It found a fragment of a shattered planet spinning nearly 5 times faster than physics comfortably allows. It caught a star that may have collapsed into a black hole without a single flash of warning. It quietly photographed a visitor from another solar system 10 days before anyone else on Earth even knew to look. And just 8 days ago, it laid its own view of the sky over 4 of humanity's greatest telescopes and saw something none of them had caught alone. We spent thousands of years looking up at a sky that seemed permanent. Fixed stars, frozen constellations, a universe so vast and so slow that a human lifetime felt too short to ever notice it move. Vera Rubin's observatory has already proven that was never true. The sky was never still. We just never had a machine capable of remembering what it looked like yesterday, so it could catch what changed today. Now we do, and it's only getting started. So, here's the real question, and I want you to actually sit with it before you go. This telescope has almost 10 years left to run. If a routine data release from last week already showed us something 4 other observatories missed for 20 years, what's waiting 6 months from now? What's waiting at year 5? How many hidden black holes have already formed in total silence that we simply haven't caught yet? How many visitors from other star systems have already passed through our solar system without a single person on Earth noticing? We're not just watching a telescope collect data anymore. We're watching the universe get caught in real time in the act of changing. If stories like this pull you in the way the universe keeps quietly rewriting what we thought we understood, subscribe, because Rubin already has more data coming this October, and I'll be covering it the moment it drops. And drop a comment. Which discovery in this video actually stopped you? The spinning asteroid? The silent star in Andromeda? Or the stacked image that beat 4 telescopes to something they missed for 20 years?